atomic radius. So atomic radius, what happens? It along the period it decreases, whereas down the group it increases. Atomic radius ಏನಾಗುತ್ತೆ? So ಎಡದಿಂದ ಬಲಕ್ಕೆ ಹೋದಂಗೆ ಇದು ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, ಸೈಜ್ ಕಡಿಮೆ ಆಗುತ್ತೆ because of a increase in the nuclear charge. Whereas down the group ಕೆಳಗಡೆ ಹೋದಂಗೆ ಏನಾಗುತ್ತೆ? Atomic radius size ದೊಡ್ಡದಾಗ್ತಾ ಹೋಗುತ್ತೆ because of the number of shell increases. Okay. Now one more term here we are having is isoelectronic species. Isoelectronic species ಅಂದ್ರೆ ಏನು? Iso ಅಂದ್ರೆ ಏನು? Iso ಅಂದ್ರೆ same. Same. What is same here? Electrons. Same number of electrons. So that is having a same number of electrons. How it becomes the same number of electrons? Either by gaining electron or losing electron. ಯಾವುದೋ ಒಂದು ನಾಲ್ಕೈದು ಸ್ಪೀಸೀಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಅಯಾನ್ಸ್ ಇರ್ಬೋದು, ಆಟಮ್ಸ್, ಎಲಿಮೆಂಟ್ಸ್ ಇರ್ಬೋದು. ಸೊ ಎಲ್ಲಾದ್ರೂ ಇಲೆಕ್ಟ್ರಾನ್ ಸೇಮ್ ಇದ್ರೆ ಅದಕ್ಕೆ ಏನಂತಾರೆ? ಐಸೋ ಇಲೆಕ್ಟ್ರಾನ್ ಸ್ಪೀಸೀಸ್. ಎಲ್ಲ ಇಲೆಕ್ಟ್ರಾನ್ ಸೇಮ್ ಇರಲಿಕ್ಕೆ ಚಾನ್ಸಸ್ ಇರುವುದಿಲ್ಲ ಯಾವುದೋ ಒಂದು ಆಟಮ್ದಾಗ. ಬೇರೆ ಬೇರೆ ಆಟಮ್ ಅಟಾಮಿಕ್ ನಂಬರ್ ಚೇಂಜ್ ಇರೋದು, ಇಲೆಕ್ಟ್ರಾನ್ ಬೇರೆ ಇರ್ತದೆ. ಬಟ್ ಅಯಾನ್ಸ್ ಇದ್ದಾಗ, ಅಯಾನ್ಸ್ ಅಂದ್ರೆ ಏನು? ಐದರ್ ಗೇನಿಂಗ್ ಎಲೆಕ್ಟ್ರಾನ್ ಆರ್ ಲಾಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್. ಇಲೆಕ್ಟ್ರಾನ್ ತಗೊಳ್ಬಹುದು ಅಥವಾ ಎಲೆಕ್ಟ್ರಾನ್ ಕೊಟ್ರೆ ಅದು ಅಯಾನ್ಸ್ ಆಗುತ್ತೆ. Depending upon that we are in cation ಮತ್ತು anion. So now isoelectronic species ದಲ್ಲಿ what happens to the what is the meaning of isoelectronic species? That is having the same number of electrons. I will take an example here. So nitrogen, its atomic number is 7. 7 atomic number ಅಂದ್ರೆ ಎಷ್ಟಾಯ್ತು? Number of electrons 7 ಇದೆ. If I add 3 electrons, ಅದಕ್ಕೆ 3 electrons ಹಾಕಿದ್ರೆ ಮತ್ತೆ ಕೊಟ್ರೆ ಏನಾಗುತ್ತೆ ಅವಾಗ? ಸೊ ನಂಬರ್ ಆಫ್ electrons 10. electrons ಅಷ್ಟೇ ಹಾಕ್ತೇವೆ, protons ಹಾಕುವುದಿಲ್ಲ. ಅದಕ್ಕಾಗಿ ಏನಾಗುತ್ತೆ? ಚಾರ್ಜ್ ಹೆಚ್ಚಿಗೆ ಆಗುತ್ತೆ. ಸೊ here charge becomes 3 minus. Nitrogen 3 electrons are we are adding, so it is 3. So how many total number of electrons now here? It is 10 electrons. ಮುಂಚೆ 7 ಇತ್ತು, ಅದಕ್ಕೆ 3 ಆಡ್ ಮಾಡಿದಾಗ 10. So we look for oxygen. Oxygen atomic number 8. Number of electrons are 8. I will add 2 electrons. So L minus the electron 8. Again it becomes 10. Fluorine. If I add 1 electron. So these are called as isoelectronic species. In case of these are called as anion because they are having a negative charge. By gain of electrons they are getting a minus charge. So these are called as isoelectronic species. Okay. So neon comes. Neon is also having a head. So this is the now atomic radius ಏನಾಗುತ್ತೆ ಹೀಗಿದ್ದಾಗ? ಸೈಜ್ ಏನಾಗುತ್ತೆ? In case of anion, greater the negative charge, greater is the size. So negative charge ಹೆಚ್ಚಿಗೆ ಇದೆ nitrogen. So this is a high, radius is high, size of this ion. Both are all are isoelectronic species. So this. Okay. So this is also neon is also having a 10. It is not having any charge. Already 10 is there, so 10. Now we go for the positive. So there is a sodium. Sodium atomic number 11. So I want to make it as a 10. Number of electrons 10 ಮಾಡಬೇಕು ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ? 1 electron ಕೊಡ್ತದೆ. So when it gives 1 electron, ಒಂದು electron ಕಡಿಮೆ ಆಯಿತು, proton ಅಷ್ಟೇ ಇರ್ತದೆ. So therefore it is getting charge. So 11 is ಏನಾಯಿತು? Its number of electron is 10. Similarly magnesium. Next it is 2 plus 12 ಇರ್ತದೆ, 2 electron ಕೊಟ್ರೆ. So all these are isoelectronic species. Okay. So in case of cation, these are anions. These are cations. So cations ನಲ್ಲಿ ಏನಾಗುತ್ತೆ? So higher the charge, lower is the size. So ಇಲ್ಲಿ ಏನಾಯ್ತು? Sodium is having a size of Na+. Isoelectronic species ದಲ್ಲಿ the charge of cation is ಅದೇ ಆನಯೋಸ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಐಸೋಎಲೆಕ್ಟ್ರಾನಿಕ್ ಸ್ಪೀಸಿಸ್ ಅಲ್ಲಿ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. ವಿ ಆರ್ ಡಿಸ್ಕಸಿಂಗ್ ದ ಐಸೋಎಲೆಕ್ಟ್ರಾನಿಕ್ ಸ್ಪೀಸಿಸ್. ಸೊ in case of isoelectronic species for anions larger the size charge greater is the size. In case of cation larger the size charge smaller is the size. Okay, so this is about the isoelectronic species. Okay. So now let us go for the next periodicity, that is ionization of enthalpy. Okay. Ionization enthalpy. Ionization enthalpy. What do you mean by ionization enthalpy? It is nothing but the energy required to remove outermost electron in the ground state from a neutral gaseous atom. Very important is here na neutral gaseous atom. ಯಾವುದು atom ಅಲ್ಲ, ಅದು ಗ್ಯಾಸ್ ಫಾರ್ಮ್ ದಲ್ಲಿ ಇರಬೇಕು, ನ್ಯೂಟ್ರಲ್ ಇರಬೇಕು. Okay, and you have to remove the outermost electron. ಆ electron ತೆಗಿಬೇಕಾದ್ರೆ ಎಷ್ಟು ಎನರ್ಜಿ ಬೇಕಾಗುತ್ತೆ? So that is nothing but ionization enthalpy. Okay, ionization enthalpy, define ionization enthalpy ಅಂತ ಕೇಳಬಹುದು. Then how it varies along the period and down the road. Okay, so ionization enthalpy is nothing but the energy required to remove outermost electron, not the inner electron, ಹೊರಗಡೆ ಇರುವಂತ electron, outermost electron from an neutral gaseous atom. Neutral gaseous atom. So that is known as a ionization enthalpy. Okay. Now if you consider the along the period, what happens to the ionization enthalpy? Okay. So along the period what happens to the size? Along the period size ಏನಾಗುತ್ತೆ? Size ಕಡಿಮೆ ಆಗ್ತಾ ಬರುತ್ತೆ. Okay, along the period we know the radius, it decreases along the period. Decrease ಆಗಿದಾಗ ಏನಾಗುತ್ತೆ? Electrons ಹತ್ರ ಬರ್ತದೆ. outermost electron is very close to the nucleus. Nucleus is a positive charge. Nucleus is a positive charge. Okay. And electrons round the nucleus. Outermost electron, if you want to remove this. Okay. So they are attracted. Electrons are attracted towards the nucleus, or nucleus attracts the electron. ಈ electron ತೆಗೆಯಲಿಕ್ಕೆ ಈಸಿ ಆಗುವುದಿಲ್ಲ. ಸೈಜ್ ಕಡಿಮೆ ಆದಾಗ ಏನಾಗುತ್ತೆ? ಇನ್ನೂ ಹತ್ರ ಬರ್ತದೆ, ಆವಾಗ ಮತ್ತೆ ಹೆಚ್ಚಿಗೆ ಬೇಕಾಗುತ್ತೆ ಎನರ್ಜಿ. ಇದೇ ಇಲೆಕ್ಟ್ರಾನ್ ಇಷ್ಟು ದೂರ ಇದೆ ಅಂದ್ರೆ, ಸಪೋಸ್ ಒನ್ ಇಲೆಕ್ಟ್ರಾನ್ ಇಸ್ ಹಿಯರ್, ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ? ಇದರಲ್ಲಿ ಚಾರ್ಜ್ ಇದ್ರ ಮೇಲೆ ಅಟ್ರಾಕ್ಷನ್ ಭಾಳ ದೂರ ಇರೋದ್ರಿಂದ ಕಡಿಮೆ ಇರ್ತದೆ, ಇದನ್ನು ತೆಗೆಯಲಿಕ್ಕೆ ಈಸಿ ಆಗುತ್ತೆ. ಸೊ ಇನ್ ಕೇಸ್ ಆಫ್ ಅಲಾಂಗ್ ದ ಪೀರಿಯಡ್ ಸೈಜ್ ಡಿಕ್ರೀಸ್ ಆಗೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ? ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. Why it increases? Because the size decrease. Size decrease ಆದಾಗ ಏನಾಗುತ್ತೆ? outermost electron nucleus ಹತ್ರ ಬರ್ತದೆ. nucleus ಹತ್ರ ಬಂದಾಗ ಅದನ್ನು ತೆಗೆಯೋದು ಈಸಿ ಇಲ್ಲ. because nucleus is will attract electron attract ಮಾಡ್ತದೆ, ಅದು ತೆಗೆಯೋದಕ್ಕೆ ಹೆಚ್ಚಿಗೆ ಫೋರ್ಸ್ ಬೇಕಾಗುತ್ತೆ. So therefore along the period what happens? Along the period the ionization enthalpy it increases. Why it increases? Because of size decreases. ಅದಕ್ಕಾಗಿ ನಾನು ಹೇಳಿದ್ದು ಅಟಾಮಿಕ್ ರೇಡಿಯಸ್ ಸರಿಯಾಗಿ ನೆನಪಿಟ್ಕೋಬೇಕು. ಅಟಾಮಿಕ್ ರೇಡಿಯಸ್ ಎಲ್ಲ ಉಲ್ಟಾ ಆಗುತ್ತೆ ಎಲ್ಲ ಕಡೆ ಅಲಾಂಗ್ ದ ಪೀರಿಯಡ್. ಸೊ ಅಟಾಮಿಕ್ ರೇಡಿಯಸ್ ಡಿಕ್ರೀಸ್ ಆಗೋದ್ರಿಂದ, ಸೈಜ್ ಡಿಕ್ರೀಸ್ ಆಗೋದ್ರಿಂದ, ಸೊ ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಇನ್ಕ್ರೀಸಸ್ ಅಲಾಂಗ್ ದ ಪೀರಿಯಡ್. ದೆನ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಡೌನ್ ದ ಗ್ರೂಪ್? ಡೌನ್ ದ ಗ್ರೂಪ್ ಏನಾಗುತ್ತೆ? ಸೊ ನ್ಯೂಕ್ಲಿಯಸ್ ವಿಲ್ the size increases. Size increase ಆಗಿರೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ? ನ್ಯೂಕ್ಲಿಯಸ್ ಮತ್ತು ಲಾಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ ಡಿಸ್ಟೆನ್ಸ್ ಭಾಳ ಆಗುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ಹೊರಗಡೆ ಇರುವಂಥ ಎಲೆಕ್ಟ್ರಾನ್ ತೆಗಿಲಿಕ್ಕೆ ಈಸಿ ಆಗುತ್ತೆ, attraction kadme agutte. So therefore down the group it decreases. Okay, so down the group it decreases, along the period it increases. Now one more thing here, that is some exceptions are there. When you consider some electronic configuration, that is along the period, especially along the period, when we consider that the second period, lithium, I read with some values of these along the period: lithium, beryllium, then boron, carbon, nitrogen, oxygen, and fluorine, and neon. So ionization enthalpy for lithium, it is found to be 520. Next ಏನಾಗಬೇಕು, along the period increase ಆಗುತ್ತೆ. So 520 beryllium ಎಷ್ಟಾಗುತ್ತೆ, increase ಆಗಿ 899. The value is found to be 899. Okay. Next boron ಏನಾಗಬೇಕು, ಇಲ್ಲಿ ಹೆಚ್ಚಿಗೆ ಆಗಬೇಕು. Okay. So boron value is found to be here 801. Okay. Next carbon 1086. Nitrogen 1402. Next oxygen ಇನ್ನು ಹೆಚ್ಚಿಗೆ ಆಗಬೇಕಿತ್ತು, ಬಟ್ 1314. Then fluorine 1681. Okay, 2081. Now if you observe here the values, so increase ಆಗ್ತಾ ಇದೆ. So this is less, this is more, but here these are less side. Here more, not the less. So what we can observe here, beryllium ಮತ್ತು nitrogen ಆದ ನಂತರ ಬರುವಂತದ್ದು ಏನಾಗುತ್ತೆ, so they are having some exceptions. So as per the rule ಏನಾಗುತ್ತೆ, along the period increases. So increase ಆಗ್ತಾ ಹೋಗಿದೆ, ಹೌದು, ಅದರ ಮಧ್ಯದಲ್ಲಿ ಒಂದು ಎರಡು ಕಡೆಗೆ ಕಡಿಮೆ ಬರುತ್ತೆ. Why? This is because of its electronic configuration. When you observe the electronic configuration of a beryllium, so beryllium togondre atomic number 4, this electronic configuration 1s2 2s2, means s orbital is completely filled here. Okay, so cation L shell, cation dalli this is completely filled, L shell orbital is filled. Next boron ಏನಾಗುತ್ತೆ, so in case of boron it is 1s2 2s2 then 2p1, 1s2 cation completely filled, 2s2 2p1. So you can remove this electron very easily compared to this field. ಅದಕ್ಕಾಗಿ ಇಲ್ಲಿ ಸ್ವಲ್ಪ ಹೆಚ್ಚಿಗೆ ಬರುತ್ತೆ. So usually 801 ಬರ್ಬೋದಿತ್ತು, 700 something ಬರ್ಬೋದಿತ್ತು. Because here it is a completely filled orbital, you require extra energy. Whenever it is completely filled or half filled or completely filled, so it requires more energy. So therefore here what happens, it requires more. Whereas in case of boron, it is only one here, it is free. In pairing agila separate ಇದೆ, so you can remove that really easily. So whenever there is only one element, so therefore the reason for this is so in case of boron electronic configuration, if you observe, it is having only one electron in the p orbital, so that is very easy to remove. Hence the value is here less, whereas here it is more because completely filled up 2s orbital. Okay. Similarly, we can explain for this also. ಇಲ್ಲೇನು ನಾವು ನೈಟ್ರೋಜನ್ ಮತ್ತು ಆಕ್ಸಿಜನ್ ತಗೊಂಡ್ರೆ, so in case of nitrogen atomic number 7 is the 1s2 2s2 ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ ಸ್ಟೆಬಿಲಿಟಿ ಹೆಚ್ಚಿಗೆ ಇರ್ತದೆ. ಸೊ therefore it is a more here. Whereas in case of oxygen ನಲ್ಲಿ ಏನಾಗಿರ್ತದೆ 1s2 2s2 2p4 1s2 2s2 2p4 2p4 ಆಗಿರೋದ್ರಿಂದ ಹಾಫ್ ಫಿಲ್ಡ್ ಆಗಿಲ್ಲ, ಪಾರ್ಷಿಯಲಿ ಫಿಲ್ಡ್ ಆಯಿತು. ಸೊ ಯು ಕ್ಯಾನ್ ರಿಮೂವ್ ದಿಸ್ electron easily. Okay, so this is the reason why oxygen is having a ionization enthalpy less than the nitrogen. Give reason ಅಂತ ಕೇಳಬಹುದು. Because in case of nitrogen it is half filled is more stable, you require extra energy to remove because its stability is increases when it is a half filled or completely filled. So whereas in case of oxygen it is not a half filled, it is partially filled. Illondu extra electron ಇದೆ illondu, so this is all free. So therefore it is a very easy to remove that electron, hence ionization enthalpy of oxygen is a less. Okay, so this is how to explain this ionization enthalpy with respect to the along the period and down the group. So along the period ಏನಾಗುತ್ತೆ increase ಆಗುತ್ತೆ. Why it increases? Because of size decreases. Down the group it decreases. Why it decreases? Because size increases. Okay, so these are the exceptions you have to remember. So this is about the ionization enthalpy. Then depending upon how much electrons you are going to remove, so that is all we are having first ionization enthalpy, second ionization enthalpy, third ionization enthalpy, like that. So only one electron ನಾವು ತೆಗಿತಾ ಇದ್ದೇವೆ ಅಂದ್ರೆ outermost electron, only first electron, so then it is called as the first ionization enthalpy. ಎರಡು electron ತೆಗಿಬೇಕು ನನಗೆ, so then second ionization enthalpy. Then second ionization enthalpy normally is more than the first ionization enthalpy. Okay, because the nuclear charge ಹೆಚ್ಚಿಗೆ ಆದಂಗೆ ionization enthalpy ಹೆಚ್ಚಿಗೆ ಆಗ್ತಾ ಹೋಗ್ತದೆ. Okay, so this is about the ionization enthalpy. So now let us go for the next trend, that is electron gain enthalpy. Electron gain enthalpy. So here also it gives a meaning of that electron gain enthalpy. How much energy is required to get an electron? Electron gain ಮಾಡಬೇಕು ಅಂದ್ರೆ electron ಅನ್ನು ಹಾಕಬೇಕು neutral charge. So it is also same thing here, it is the energy required. Here depending upon the type of element it is a exothermic or endothermic ಆಗುತ್ತೆ. Okay, so how much energy is required to add electron to the gaseous neutral atom? Gaseous ಇರಬೇಕು, neutral atom ಇರಬೇಕು, ಅದಕ್ಕೆ ನಾವು electron ಹಾಕಬೇಕಾದ್ರೆ ಎಷ್ಟು ಎನರ್ಜಿ ಲಿಬರೇಟ್ ಆಗಬಹುದು ಅಥವಾ ಎಷ್ಟು ಎನರ್ಜಿ ಬೇಕಾಗಬಹುದು. So that is nothing but electron gain enthalpy. Okay, so it depends upon the element. So depending upon the element, the process may be exothermic. Exothermic ಅಂದ್ರೆ ಏನು? Heat is evolved. Endothermic means heat is absorbed. So in this case also same thing, along the period and down the group. Along the period. See, depending upon once again your electronic configuration, the electron gain enthalpy changes. So every element they want to become take 8 electrons, octet configuration ಆಗಬೇಕು ಅಥವಾ noble gas configuration ಬರಬೇಕು ಅನ್ನುವಂಥದ್ದು so intention ಇದೆ. So therefore that is done by either gaining or sharing or donating electrons ಆಗಿರ್ತದೆ. So here we are mentioning about electron gain enthalpy. So if you add electron, so that depending upon the element it is a exothermic and endothermic. So along the period, once again here it is a so reverse of the radius, it is a increases. Along the period it increases because the nuclear charge increases. Okay, so therefore if you want to add electron, the electron gain enthalpy increases along along the period. Then down the group, so let us take here some values. Okay, here also we have to consider some values here. So along the period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Values are found to be here is minus 59.8. This is 0. Then 27 minus 122.3 minus 31 minus 140 minus 322 G. So here we have mentioned it is increase. So here negative sign indicates that is the exothermic. Okay. So increase of the number on that. But once again here also we can find there is some beryllium 0 ಇದೆ. So ಇಲ್ಲಿ increase ಆಗಬೇಕಾಗಿತ್ತು, ಇಲ್ಲಿ minus ಕಡಿಮೆ ಆಯ್ತು, 31 ಕಡಿಮೆ ಆಯ್ತು ಮತ್ತೆ. So why this happens? Again same reason what we have taken earlier, it's electronic configuration. In case of beryllium that is it is the 1s2 2s2 1s2 2s2. And next is here p orbitals also there. Idu khali enagutte, so you can add electron here because so it is entirely different orbital here and you are adding that electron to here. So therefore it will take electron, hence the value is 0. It is not requiring much energy to add an electron to beryllium. Okay. So further ಏನಾಗುತ್ತೆ, next ಇದರಲ್ಲಿ ಒಂದು ಆಲ್ರೆಡಿ electron ಇರುತ್ತಾ ಕಡಿಮೆ ಆಗುತ್ತೆ. So next in case of nitrogen, so in case of nitrogen electronic configuration 1s2 2s2 2p3. So here there is a 3 orbitals, p orbitals. So they are in a half field. So they will allow the electron to come and take these positions. So therefore it requires a lesser energy. So here also in case of a half filled or empty, in case of neon empty, completely ಎಲ್ಲ fill ಆಗಿಬಿಟ್ಟಿದೆ. So next orbital next cell ಗೆ ಹೋಗ್ಬಿಡ್ತದೆ. So easy ಆಗಿ ಹೋಗುತ್ತೆ, ಅಲ್ಲಿ ನಮಗೆ ಎನರ್ಜಿ ಬೇಕಂತಿಲ್ಲ. So here next orbital ಹೋಗುತ್ತೆ. So p orbital, it is also empty. So therefore the values are here 0 and 31 and 0. So this is about the along the period, some exceptions. So it increases, but in case of some of the elements, because of its electronic configuration, we can say that is the values are some variation in the values is found. Next is down the group. So what happens now? Electron gain enthalpy down the group. So ಏನಾಗಬೇಕು, it decreases. It decreases down the group. Electron gain enthalpy decreases down the group. So this is about the ionization enthalpy, electron gain enthalpy. So it gives some values of electron gain enthalpy down the group also. Lithium, sodium, potassium, rubidium, cesium. This is minus 60, minus 53, minus 48, minus 47, minus 46. So here decreases, but not much. especially when you come down, so not much because of the increase in the there is a d orbitals, presence of d orbitals bರ್ತದೆ next. And also here a nuclear charge increases. So nuclear charge, effective nuclear charge decreases, and the down the group electron gain enthalpy decreases. Okay. And also the number of cells also increases, so we can add up electron without much of effort. Shell ಹೆಚ್ಚಿಗೆ ಆದಾಗ ಏನಾಗುತ್ತೆ, ನ್ಯೂಕ್ಲಿಯಸ್ ದೂರ ಆಗ್ತಾ ಹೋಗ್ತದೆ. We can add electron very easily without much investment of energy. So therefore it decreases down the road. Whereas along the period ಏನಾಗುತ್ತೆ, ನ್ಯೂಕ್ಲಿಯಸ್ ಹತ್ರ ಇರೋದ್ರಿಂದ ನಾವು ಆ್ಯಡ್ ಮಾಡಲಿಕ್ಕೆ ಆಗೋದಿಲ್ಲ ಅಷ್ಟು ಸುಲಭವಾಗಿ, ಸೈಜ್ ಕಡಿಮೆ ಇರೋದ್ರಿಂದ. Okay, repulsion ಹೆಚ್ಚಿಗೆ ಆಗುತ್ತೆ. So you have to extra force, you have to extra energy you have to put. So this is about the electron gain enthalpy.